Hello everyone, this is Mohammed Sarfaraz. I am an assistant professor in a mechanical department. I work in a engineering college, Halawar. Today we are going to discuss about the subject power generation. It's 8 semester subject and the subject code is 8 in 3A. So today's topic is that uh, power generation subject second unit, that is gas turbine power plant, and gas turbine. It is also called the Brayton cycle. So let's see. So here's the content. You can see what are the content are there for the gas turbine power plant or gas power plant, and it's also called Brayton cycle because it is developed by the scientists researcher. We can say that's Brayton. And in this slide or in this lecture, we are going to discuss the following topic. First is about the gas turbine power plant, and the second is history about it, and the third is what are the gas turbine power plant and what's the working, and next is where is the application of this power plant and what are the advantages of using this as compared to steam turbine, and what are the disadvantages, and next is different types of gas turbine power plant, and next is open cycle, next is what's about the types of cycle, that is open cycle, what is closed cycle, and the next uh, part we will discuss about the PV and TS diagram of the Brayton cycle, and next about the basic entropy, what about basic cycle about entropy, what is entropy. So and next we are going to discuss about how we can improve the thermal efficiency of this gas turbine power plant. They are basically this is same as the kind cycle where we are using to improve the thermal efficiency. There are basically three methods are there. First, regeneration and reheating and intercooling is there, and we have already discussed this discussed this type of method in a Rankine cycle. So here is the same. So gas turbine power plant, as we know that this is same as a same. We can't say same, but it's somehow same as Rankine cycle. The only difference is that here we are using compressor, and for uh, combustion we use a combustion chamber here, and a different type of fuel is using here. So there is a but the application of this cycle is same as the Rankine cycle, that we are using this for the generation of electricity, and also it is used for aircraft system and air propulsion system and our ship in a marine system. So let's see what is gas turbine power plant. It's nothing but it's a type of power plant which is working with cycle, and it's use fossil fuel power station in the power system which burn the fossil fuel such as coal and natural gas, petroleum to produce electricity. Here we are used as a fuel like coal, natural gas, and petroleum. Fossil fuel power station high machinery to convert the heat energy into the combustion into the mechanical energy, which then operate on electrical generation. So here is the history of the gas turbine power plant. Is generated, as I have already told you, it's also carbon cycle. It is developed by the scientist Brayton, and it was first used for power generation in 1939 in Switzerland, and the company which is used commercial purpose, that company was Pond Bowie. So here you can see the basic types of gas cycle. Here we are using fuel as a natural gases, petroleum like that, and gas turbine is also called combustion turbine, as we know that it's a type of internal combustion engine, and the basic operation of the gas turbine is similar that is steam turbine power plant, except that air is used instead of water. As we know that in a steam turbine power plant, in a Rankine cycle, we are using steam, that is water is converted to steam, but here we are not using water. So there is an advantage that we don't use water here, but in spite of water, we are using here natural gases for burning purpose. And the phase here, obviously, as we know that oxygen is required for the burning, that's why we are using. So as a working principle, as we know that this cycle is mainly consists of the three main component. First is compressor, and secondly combustion chamber, third is turbine. Turbine is very important because it's the main part which produces work, or we can say power. So application of gas turbine power plant, as we already told you about the application, that is it is used in various purposes. The main purpose is power generation, and the second is aviation system, aviation sector, that is for the for the lightweight aircraft like that, and the third is it is used in oil and gas industry, As we know, the cheaper fuel supply or low installation cost is there. And the next important application is power marine propulsion. That is a very large ships. An advantage, as I already told you, it's a compact design and high speed, high power is there. And next is less pollution, and third is water is less amount of water is required. And next is simple lubrication system. Next is its cost of maintenance is very less, and is also required low storage of fuel. And the next is the gas turbine can be run at a very high speed, that is 40,000 rpm. We can drive this turbine. And the main disadvantage of this gas turbine power plant compared to cycle is that we are using compressor. So for driving this compressor, we used to given power. We have to give power to this compressor. So whatever amount of energy or power we are generating, of 66% of this energy or power we have to given to the compressor to drive this compressor. So that's the main disadvantage of this cycle. And next is there is a noise, very high noise is there. High noise is there. That's the problem. And third is starting the power plant cost is very costly. That is not simple. And next is compared to the power plant, power efficiency of this plant is quite low. So that's a disadvantage of that was a disadvantage of power plant. And next is the types of power gas turbine power plant. As I have told you, there's basically two types of gas turbine power plant. And first is open cycle, and next is closed cycle gas turbine power plant. In an open cycle gas turbine power plant, as we know that whatever air we are taking, that water or atmosphere we are charging into this cycle, and the exhaust after the exhaust of the turbine, it is not we using in this cycle. That's open cycle gas turbine power plant. And in a closed cycle gas turbine plant, we are using the constant amount of air, and apart from this we are using some another fuel working medium, and this is circulated after the turbine exhaust. This is circulated in this cycle. So that's a closed cycle of gas turbine power plant. And in the open cycle gas turbine plant usually operate in open cycle, as we know that. And usually there's a most of power plant gas turbine is operating in an open cycle. There is an independent condition drawn into the compressor, where temperature and pressure rise. So high pressure air pressure into the compressor chamber, as we know that, where the fuel is burned, and the constant pressure, then high temperature gases enter into the turbine, where they expand into the atmosphere, and pressure help producing the power. So like that the power is produced there. So here we are going to end this lecture, that's open gas turbine power plant. On the next lecture we are going to discuss about the remaining part, that is what are the PVTS diagram, how it is working, and how we can improve the efficiency in a next lecture. Okay, discuss. Okay, so thanks for the lecture. Okay, thank you.